Hello again, dear students. I'm glad to meet you again in this session, which I'm going to talk about algebra expression, the 1.3, chapter 1, section 3. So when in mathematics, when we say, or in college algebra, when you say we have an expression, means that we have something that very important, because these expressions sometimes are our equations, sometimes they are changed to the inequality. So this is very important to do and to distinguish between them, which I will give you more information about later. In this section, I'm going to tell you about some concepts on mathematics concepts with some polynomial zor der in Kurdish. So in this term, we are going to add and subtract them and multiply them and divide them and finding something that they are very interesting if you are going to or if you are ready to be with me and do your homework with me. So in this case, when I say polynomial, so in that case we have some expression like that. So expression means that something that is like that. Okay. we have a degree and term for this one. Also we sometimes we say we have a leading term. Now for here, for example, I have x to power 2 minus 5x, will be x to power 3x to power 3. Okay, x to power 2, 5x. These terms are we see this is a polynomial with the degree, the highest degree. We will count the highest or the maximum power or highest power. So in this case we say we have a polynomial with the which is 1, 2, 3, 4 terms. Okay, 4 terms, and the degree with the degree 3. That's all. Also, we recall these numbers a, b, c, or a1, an, a2, anything as a coefficient. How coefficient? Okay, so in that case, when we have something like that, we have a polynomial. There's a special case, or there are some special name like a polynomial. We have a trinomial. When I say trinomial, tri in math, when you say bi means that 2. When you say tri, it means that you have 3. So when I say trinomial, means that 1, 2, 3, we have 3 terms, and the degree is what? The degree is 2. How about this one? 1, 2. So that's the term, and how about the degree is 2. Now what in this case I have binomial 1, 2, and with the degree 8. That's all that you need to know about this one. So when we have nothing, you see monomial means that we have one term. Okay, with the degree 0. This is the monomial with the degree 5. Okay, monomial means that we have one term as monomial. This is just for clarifying, or if in case you use another book or reference, so you know how to deal with it and you know what do you mean by monomial. Now we have an operation or operator on the polynomials. So we have the operator, I mean the addition and subtraction. They are very easy. First of all, try to order them. When I say order, means that from the highest degree, order from the higher degree to the lower degree. Okay, dear. So how we arrange this one? Now I have x to power 3, for example. I have x to power 3, which is the example one in page 20, I think. 20, yeah, page 20 in your lecture note that you have. So in this example, part A, we have what? We have x to power 3 minus 6x squared plus 2x plus 4, all of them addition with x cubed plus 5x squared minus 7x. So when I say try to order them, so means that because you have addition, these parentheses, they are not important. This is first of all. Okay, so I have what? X to power 3 minus 6x squared plus 2x plus 4. Another parenthesis, we have plus x to power 3, 5x squared minus 7x. This is the first step. In the second step, try to arrange them. Means that x to power 3 with the x to power 3. That's this is the order, or arranging it from the highest to the lowest exponent. So I have x to power 3 plus x to power 3. Okay. Next, we have what? We have minus 6x squared. Where's the x? Another x squared. Here is it. So 5x squared. Again, what's the after the x squared? Surely you have a plus 2x. Plus 2x. Again, I have what? I have minus 7x. Okay, dear? Minus 7x. So again, or later, what we have? Just the numbers maybe remains. So we have number 4 without anything. So it means that x to power 0. So this is your common things that you have after arranging it. So 1 is equal to 2x cubed minus 6 plus 5. It remains just 1x squared minus 6 plus 5. Again, we have minus 7 plus 2x. So it remains between 5 and 7 and 2. We get 5 and x, and also 4. That's all that you need. How about subtraction? The subtraction you can find in the another example, the same, minus 6x plus 2x, square, plus 4. Okay. Again, we have what? X cubed plus 5x, the same example, I think, minus 7. But now we have what? We have subtraction. In this case, when you want to subtract between them, please put the first down. Right, it's as you have, and because I have a negative and there's parentheses, you cannot say I will neglect this parentheses. No, try to multiply with the signs. So the sign of x, so we have x cubed. Now I say minus x cubed. Again, negative multiply positive, I get negative 5x squared. Negative by negative, I will get positive 7x. That's all that you need. And again, try to arrange them. Now I have x cubed minus x cubed. Okay, what else? Minus x squared minus 5x squared again, and then again. So what else? 2x, 7x. What else? Plus 4. That's all that you need. So plus minus will cancel each other. Minus minus, I will get minus 11x squared. So 2 to 7. Now I'm nearly to get what? To 9x plus 4. That's all that you need. Okay, they are easy, and you can see, or you can compare with your with the solution that you have in the book. Now it's time to try to solve two new or two more example about this page, about this subtraction and addition between two polynomials. So in page 21, we have another operation. When I say operation, I mean addition, subtraction, multiplication, division. Now we talked about this one. Now it's time to multiplication. Between what? Between two expressions. Okay, between two expressions. So how we multiply this one? As a standard way, you have a FOIL first. Okay, then the again the another things that you need to multiply, we recall as a FOIL, first, second, and the last one, and we have a O and I. Okay, in this case, I think you know how to multiply them. And also we have maybe binomial by binomial or binomial by trinomial. There's no difference. You have the same strategy that you have. So I will leave this example because they are very easy, just phase by phase. Now I'm doing it here on the lecture. Okay, I'll do it. Okay, now I have what? I have x. I have 2x multiply first to first. So 2 by 3, number by number. So I say 2 by 3, I will get 6. And x by x, as you know, in the 1.1, x by x, you'll get x squared. The base are equal, so we add the power or the exponent. Okay, so that's why I will get what? I will get x square here. Okay, dear. So now I will get x square. 2 by 3 is equal to 6. X by x is equal to x square. Now, first to the second. So 2 by 5, I will get 10. 2 by 5, I will get 10. And x with nothing means that just x. Now, how about the negative? I will put as a positive multiply negative. I get negative. So 2 by 5 is equal to 10. X by means that x to power 0, or there's nothing. I will say x just equal to x. Again, the second to the first one. Okay, so 1 by 3 is equal to 3. Nothing by x, I will get x, as I told you before in the 1.1. Now 5, 1 by 5, I will get 5. So, as I said in the page 20, we have addition between these two, or subtraction, as you can say. So we have 7 minus 10 plus 3, which is equal to minus 7. That's all that you need. How about the other example? For example, I have trinomial by binomial. So I have 2x. Okay, the example 3 in page 21. So I have 2x plus 3. Okay, dear. Sorry. I have what? X squared minus 5x plus 4. Now it's time to multiply these binomial by trinomial. So as I told you, to the first is equal to what? 2 by nothing. I get 2, or let's say 2 by 1. So x by x squared, x by x squared, I get what? Look, x multiply x squared. The base are equal, so I say x to power 1 plus 2, which is equal to x cubed. So that's all. So it's equal to 2x cubed. Okay. Now again, the time of multiply the first by the second. So addition by subtraction, or positive by negative, I will get negative. 2 by 5 is equal to 10. X by x is equal to x squared. Okay, dear. And 2 by 4 is equal to addition 8 and positive, or surely, because I have positive by positive, or negative, positive by positive is equal to positive result. X by nothing, or x to power 0, is equal to x. Now it's the time for multiplying the second. So 2x, when I say we multiply 2 by all of them by trinomial. Now it's the time for the second. Now is equal to what? 1, 3, we have a positive by positive. Now 3 by 1 is equal to 3. Nothing by x squared, I'll get x squared. Okay, dear. Now again, for the second term, so positive by negative, موجب كرتي سالب, is equal to negative. And 3 by 5 is equal to 15. And nothing by x, I will get x. Okay. Now again, positive by positive is equal to positive. 3 by 4 is equal to 12. Now it's the time to manage these numbers. How we manage these numbers? How we arrange these expression, as I told you, from the highest to the lowest. So minus 10x squared. Now I have what? I have also 3x squared. Now it's time for x. 8x, negative 15x, and plus 12. That's all that we have. Okay, dear. So is equal to what? As you know, there's nothing with this to compare or addition or subtraction. So negative 10 plus 3 is equal to minus 7, because both of them, they are the same exponent. That's why. So you cannot add or subtract x to power 2 with the x to power 3. Okay, just you can add or subtract with the same exponent. Now I have a 8x, 15x, so it remains minus 7x plus 12. That's all that you have. And try to solve this one at home by your hands, because as I told you, one of the best methods for learning math is what is by doing yourself. Okay, dear, that's all that you need, and forget about the this solution, or you can also follow it in the exam or the other part, but for me it's okay. But for you, if you like it, just use the one method. And there's another example for comparing yourself. Did you get the idea or not? Now we have some special product formula. When I say product, I mean multiplication. Okay, so we have we taught about addition, subtraction, and multiplication, but there's something special in the multiplication, which is very important for us. They help you to do it quickly. Okay, do it quickly. So they are very important to follow these rules. For example, in the first, we say we have two bracket, two parentheses, the same content in it, so a b b. But if the one of them, and we have two binomial, do not forget about this one. So the first binomial is addition between them, and in the second binomial we have subtraction. So directly, without using one by one, just write it what? Write down a square minus b square. Okay, dear? So that's all that you need. So this one's called sum and product of the same terms. Sum and product of sum and product of the same terms. That's why. Also, in the lecture we will say this is the difference between two cube. So try to learn these multiplication is equal to 1, because later we will factor this one to that one. So please, we need it. So try to control them from now. So in case you have two bracket with the same. How about a square of sum? Okay, so I say the first square plus, because I have a plus 2 first by the second plus the second square. Yakam duja duon yakam zarbi duon zaidan duon duja. Okay, how about if I have a negative square of the difference, square of the sum, square of the difference? I say the first square minus, okay, minus 2 1 by 2 first by the second plus always the second square. How about cube of sum? Means that we have a bracket, parenthesis, cube on it, raised up to a cube, but there's a sum between them, because later we have a difference. So we say the first cube plus, because you have a plus here, I say the plus, okay, 3 second square by the cube of the first, and again 3 by ab square, or first second square plus b cube. Now they are really is not good, and you should memorize them. But if you solved a lot of example, you don't memorize them, you just deal with them. So that's why I say please try to solve the examples. How about difference between cube of difference? We say first cube minus 3. Again, the same thing, but there's a 2 sign is changing, as if you compare the 4 with the third, with the fifth, and if you compare the second with the third one. So if there's no example, I will give you example surely to get the idea of how to deal with this one. Now these two examples, okay, example in the page 22, go to the page 22 in your lecture note and see or focus about example example number 4 there, and also later try to solve 29 and 41, because they are very important really to get the idea. Okay, now I'm not memorizing them, but I know how to solve this one. How? Example 4, page 22, part A. So if I have 3x plus 5 square, so I say the sum of, or square of sum, I have a square, I say first square, because I have a plus, I say plus 2 first second, usually plus second square. Okay, so which of them is the first? This is the A, which of them is b? That's b. So I say 3x, and I say 5. I think it's easy. We said rule number, as I say, rule number 2. The second property, or the second formula. So in that case, I say 9x squared plus 2 by 3, 6x by 5 is equal to 30x. So, and 25. That's all we needed. Okay, so you don't need to memorize all these formula, but if you solve a lot of example, you can deal with it. So now, again and again, we have what? We have x squared. I will change this one to the easier one, then later I will solve for you, okay? To 2 cube, okay? I changed this one, really it's not b, it's a more example, extra example, okay? I changed this is in your lecture is x squared, but forget about x squared because I wanna deal with that one later. I'll complicate it for you, okay? Because you need really gradually to deal with the section. So this one I say what? This is the cube of the difference. So I say first cube, okay? Because I have negative, I say negative 3, sorry, as usual, 3 second or second square first plus 3 and b cube. Okay, I'll write it down again for you. I say it's equal to first cube minus 3 first square, sorry, second plus 3 second square minus the second cube. So I have a and b. So I say a, and now time for b, 3a, 1, 2, 3, 3b, 1, 2, 3, because I have a cube. Okay, so if you see that power of a 3, 2, 1, 0, or nothing, or if you look at the power b 3, 2, 1, nothing. So where's a is x. So where's ax? Where's ax? Now there's no b. Where's b? I have 2. Where's b? I have 2. Where's b? I have 2. That's all that you need. Sorry. Okay. Now I have x cubed. 3 by 2 is equal to 6x squared. 3 by 4 is equal to 12x minus 8. That's all that you have. This is I dealt with this one. I solved this one by what? By following the formula, the fifth formula. We have what? Cube of difference. Okay. So this is the cube of difference. Now I am complicating, or part B of example for page 22. I'll complicate this example for you. Why? Because you need to manipulate with the exponent. So I say the same cube. I have minus 3 a squared b plus 3 ab squared negative b cube. Okay, as I told you, 1, 2, 3, and 1, 2, 3 for b. So I have x squared, x squared, x squared. Now b is equal to what? 2, 2, 2. Now how about the exponent? I will get 2 by 3 in the 1.1. We have amn, and I said is equal to amn. We multiply. So 2 by 3 is equal to 6. Now 3 by 2 is equal to 6. 2 by 2, I means x to power 2, all of them 2. 2 by 2 is equal to 4. Plus 3, we have x squared here. So 3 by 4 is equal to 12. Okay, dear. Minus 8 as we have. And you can compare the solution to yourself in case that you need more details. Okay, so try to solve this one really at home, especially 29 and 41. That's all that we have. How about this example? I will leave this one for you. or I'll give you the trick, or the I'll give you the detail of the how to solve it, but do it by yourself. How about a? Now, what is this? Now I have a multiplication. As you see, we have a addition, because you can see we have two brackets. That's why. So now I have what? I have two brackets multiplied, which they are the first like a, the second also here's a. Now I have b, also b. There's addition and multiplication. So I get what? As I told you, we have you can do it by your slowly 1 2 1 2 binomial by binomial, or you can use the first formula directly and you see we have a sum and product of the same terms. So I have what? Sum and product of the same terms by this rule. By the following the first formula, I say to example 5. Okay, example 5, page 22. A, you see, I will say is equal a square minus b square, which means that is equal to 2x square minus this, was equal to 4x square minus y. That's all that you need to do it. Okay, dear? I think it's clear. There's nothing to be worried about it. Just read these formula, read them, and put in each one x, for example 2x2, like that, x square number 5, x square number 4. That's all that you need to replace a, b by the mathematics expression. That's all that you need. How about b? Think about this one is a, and I have what? Negative and positive. So think about b to be a, b to be a, to be 1. So this is b and that one is a. So try to apply formula 1 and you will get the result. Okay, dear? That's very important here. And try to deal with the special products formula and not just memorize them, try to apply them and solve more example on it. We have to continue in this section. We have two important words, subfactoring and common factor. Okay, so factoring, common factor. When I say factor, means that I need parentheses, I want a brackets like that. So I have the expression. When I say factor there, means that try to put or try to change it to the brackets, parentheses. Okay, or taking common. When I say expand means that I have a bracket, parentheses, and multiply them to give me one expression without any brackets. دوشتمان هەیە لە شیتەڵکردنی ئەمە کردنی بە کەوانە پێڵین فاکتەر واتە کەوانە، یان ئەڵین ئەکسپاندیکە واتە لێکدان، ئەمایان کەوانە واتە هاوبەش. Okay, so when I say factor means that I have this side and I'll give you this one. Please find this. When I say expand means that I have that one and find this one for me. That's all that you needed about factoring and factors and this one. So from now our question will be finding or factoring the following. Okay, our question will be by find and factoring the following. So now I'm going to page 23 and I'll tell you what you need, what's the important things to find when I say factor or when I say find the common between them. One minute, find it. Okay, good. In the first part, I'm factoring this one. Later I'm tell you some trick about trinomial, or maybe the other video I'll do for you. Here you have what? Page 23. So factor out common factor. Factoring out common factor means that find the factor. So what do you mean by find factor? I mean that find the common. What do you mean by finding the common? Means that if there is something here, please try to find to factor them. So there's your example 3x squared, example 6, page 23, A. So 3x squared minus 6x. So factor. When I say factor, I told you, I mean what? I mean find the parentheses, or change this expression to the parentheses. So first try to start with the number. Between 3 and 6 we have a common, surely. So it remains x squared minus 2x. Look, I took the 3 as a common factor. Okay. Now, how about between x squared and x? Try to take in the smallest exponent to out. So I say is equal to 3. Now time to x to come out. Between x squared and x is the smallest one. So I'll take the x and I'll subtract x to here. So I'll get x minus 2. That's all that I needed. I think it's easy. How about B, part B? We have what? The same example, part B. We have 8x to power 4, y2 plus 6x cubed, y cubed minus 2xy to power 4. So really this is my interesting example, because between 2, 6, 8, first of all I'm thinking about what? About 2, because the smallest number, so it remains 4. As you know, 2 by 4 is equal to 8. And plus I will get 3y, because if you divide it you get 3. So divided 2 by 8 you get 4. Divide 6 by 2 you get 3. X cubed y3 minus xy, because if you divide 2 by 2 you will get 1. That's why. Now it's time to get out, or bringing out, smallest x between x cubed and x to power 4. Which of them is the smallest? Surely x. So it remains what? 4x. Now y squared. So x to power 4. If I am taking the x to out, so I will get what? 4 minus 1 is equal to 3. Cube the same. So x to power 3. We took the 1 to out, so it remains what? X to power 2. Again x to power 1, and took it out, so there is nothing, so it just remains y to power 4. Now it's time for getting, or for outing, or factoring y. So which of them is smallest one? I think y squared, right? So 4x cubed remains. So if I put y squared to out, there is nothing. So 3x squared. We are not dealing with the x. So I have y to power 3. If I took y to power 2 from it, it remains what? We have a 3. Took 1, it remains y to power 2. Now how about y to power 4? It remains y to power 2. That's all that we needed for you to do it here. So that's the factor. That's the example and the result that you have. Now how about this one? How about this one? Look, it's an interesting example. We have in the C, part C, we have 2x plus 4, x minus 3, minus 5, x minus 3. Now look, here's the common. We have what as a common? So factor means that find the common. So if I put x minus 3, it remains what? This is minus 5. Do not forget about this one, minus 5. So if I took this one as out as a common, so it remains this part, 2x plus 4 minus 5. That's all that we need. And you know, there is something that we can do it here in the brackets. So 2x plus 4 minus 5 remains minus 1. That's all that we need. I think it's easy, but need more and more practice. Okay, dear. This is about the half of page 23, and try to solve x 61, 63, and 65, which they are very important, and give you the feedback about did you get this result or not. That's all. Okay, dear. Now I'm leaving you here, because in the next video I will deal with the 23 factoring terminal.